So today we are going to see an application of the stack. For that, the problem we consider is called evaluation of expressions. Normally, when we write programs, what we do is whenever some expressions are there, so expression will be represented in the form of code and we execute. But when we have the expressions should be having operands and operators, and different operators have different priorities. So according to the priority, we have to execute. Sometimes we represent the expressions without parentheses, or sometimes we represent with the parentheses. So whether with the parentheses or without parentheses, I mean, it is not so direct to evaluate the expression by the system. Therefore, certain notations usually been considered, and those things we are going to see. That is how to convert into that particular notation, and once it has been converted, how to evaluate the expression. For that, the data structure which we use, that is called the stack. Stack already we have seen that. It's a last in first out data structure. So that means the element which we inserted last, that will be taken on first. And this can be achieved by means of the two standard operations. One is called push, other one is called pop. Okay. First of all, let us see why the evaluation expression that is needed. For example, if our code that is having a statement like x is equal to, anyway, this notation refer to the assignment. X is equal to a divided by b star star c, okay, plus d star e minus a star c. Suppose we have the expression something like that. This star star means exponent, that is b power c. Okay, double star means it's an exponent. Okay, so that is something like b power c. Okay, so here you see we have not given any parenthesis, but this equation having several meaning depending on the way we interpret. So given an expression, we have to uniquely define. That's not very important. Okay. Yeah. So apart from that, as far as the operators are concerned, there are several kinds of operators available. These are some of the arithmetic operators, right? Apart from that, you may have unary plus, unary minus, mod, seal, floor, or comparative operators like less than or equal to, greater than. So there are several operators that can come. Okay, now let us assume some values for these variables. Variables means operands. Okay, so let us assume that a is equal to 4, b is equal to 2, c equal to 2, then d is equal to 3, and e is equal to 3. Suppose we assign these values for the operands present in this expression, then if the expression is something like that, for example, a, we can give some parentheses, the way in which we evaluate. Okay, so b star star c, then plus d star e minus a star e. This parenthesis gives the order in which we evaluate the expression. So if you do that, what happens? Here a is equal to 4. 4 divided by b star star c. So b and c are 2. So 2 for 2, that is 4, right? 2 for 2 is equal to 4 plus d into e. D into e means 9, right? D equal to 3, e equal to 3, 9. Minus a into c. A equal to 4, c equal to, so that is equal to 8. Okay, that is equal to 8. Now again we can give the parenthesis. So we assume this way, the first two things, then these two like that. So this is equal to 4 by 4 2 plus 1. So that is equal to 3. Sorry, 4 by 2, 4 by 4 what? 1 plus 1 2, right? 1 plus 1 2. So this answer we get. Suppose the same expression if we take like that, that is two operator, first two operator, then second two operator, something like that. So it will be like A divided B, okay, then star star, then C plus D, okay, C plus D, then star, then E minus A, then star C. Okay, so first two operands, the next two operands, something like that taking. So in this case, A divided by B, so that is 2, then star star, C plus D, so that is 5, right? C plus D, that is equal to 5, and star E minus A. So E is equal to 3, A equal to 4, so that is equal to minus 1, then plus C equal to 2, right? Sorry, it's a plus, no? Plus a star, right? Star. So star. So that it star 2, right? Then that is equal to, again we can take these two first, then these two like that. Okay. So two operands, first two operands, second two operand like that. So 2 power 5 is equal to 32. So into minus 1 into that is minus 2. Now if you multiply what you get minus 64. So this answer, right? So if you change the parenthesis positions, accordingly you get different values. So that's why we are saying that given an expression, it may have different meanings depending on the way we interpret. So what we want is if things goes like that, what happens? We may not get the correct answer, right? So we have to uniquely define the expression. So that is what very important. So for that, first of all, we have to see the operators and its priorities. Okay, some standard operators which we are using that we can consider operators. And here the priority value. Priority value. So operators are star star. Okay. Then unary minus, then unary plus. Then one more thing, negation. So if these operators are there, this is unary means the only one operand will be considered, right? That is star star, unary minus, unary plus, then not. Okay, not. So negation. So all these are having priority value 6. Okay, highest priority. So all these are having highest priority, that is 6. Then if the operator is multiplication or division, if these two operators comes the priority, that is equal to 5. Then next arithmetic operator plus and minus, right? For that the priority is 4. Then comparative operator less than or equal to, not less than, etc. So all comparison equal to comparison like that. So all these comparisons we assume the priority is 3. Then AND operator, that is a Boolean operator, right? AND. So that is priority 2. Then OR operator, the priority 1. Okay, these are the some of the operators we usually consider. So only those things we have taken. Accordingly, we have assigned the priorities. Remember the top one, that is exponent, unary minus, unary plus, and negation or not. So these are having highest priority 6. Okay, now if you assign the priority and you have the expression that contains two operators of same priority. Okay, we assume that we are not at all giving the parenthesis. Without parenthesis, we are giving the expression. Okay, but whether we use the parenthesis or not using the parenthesis, but uniquely we have to represent. But how we have to represent that we are looking at. Okay, as a first part, we assume that the expression having two operators of same priority. For example, we take the topmost one. If you have something like minus A star star B, minus A star star B. So now you see this is a unary minus, this is exponent. So both are having priority 6. Okay, now how we evaluate? Whether we evaluate this as minus A star star B, okay, or whether we evaluate minus A star star B. So there are two ways we can consider, right? So whether we consider this or consider this, that's a question we are getting. Okay, now I can clarify this with another way. Suppose we have something like A star star B star star C. Suppose we have like that. So what is this? This is A power B power C, right? A power B power C. So if this is the case, what we do? First we evaluate this, right? Then only that value will be considered as a power, and we take A power that value. So here the evaluation, if you give the parenthesis, what happens? You get A star star B star star C. So this is what we get, right? Therefore, when this comes, the evaluation is from right to left, right? First the parenthesis is from right to left. Okay, so now we define a rule. The rule says that if the same operators come with the priority number 6, okay, for all the operators with the priority number 6, the evaluation will be from right to left. And for the remaining priorities, the evaluation will be from left to right. Evaluation will be from left to right. So that means if we have A plus B minus C, so plus and minus having same priority, right? So here evaluation is first we will take A plus B, then minus C. Okay. So our rule is like this. The operators with the priority value 6 will be evaluated from right to left, and all other operators having remaining priorities, that is 1 to 5, will be evaluated from left to right. So this rule we follow. But okay, as a human we can do that, but as a system, how the system will look at and do that? So because it's a combination of all operators, the system has to uniquely consider the expression and do the evaluation. Then only we get the correct answer. Okay. For that, okay. Before going into that, let us see the different notation. We will come to that. That time it will be clear. So based on these priority values, we put some logic, and if we apply the logic, automatically we get that. But the question is what we get. So what we get is it should be in certain representation. So that we call as notation. So as far as expression is concerned, the expression can be given in three different ways or three different notations. One is called infix notation, other one is called the prefix notation, and the third one is called the postfix representation. So infix, prefix, and postfix. Okay. There are a lot of things we can discuss among this, but first we can consider this. So infix representation is what we generally write, right? So the operator will lie in between the operands. For example, if you have a binary operator. So normally you have binary operator or unary operator, right? So unary operator, anyway the operator will come before to that, before to the operand. Okay, no problem. That minus A, minus 3, minus 2, something or plus 2, like that. So these unary operator not of A, like that. Okay. So unary operator, no problem. We will put the operator before the operand. Fine. So when you take a binary operator, what happens? Binary operator, but two operands are there. So A plus B, A minus B, something like that. So in this case, the infix representation, the operator will come in between the operand. Operator will come in between the operand. Okay. So in the prefix representation, what happens is the operator will come before the operand. Operator will come before the operands. So for example, if you want to say A plus B, it should be given as plus AB, plus AB, like that. Okay. So the operator will come before that. That is prefix. We are fixing the operator before, prefix. Infix means in between. Okay. And similarly, postfix means the operator will come after the operands. Okay. So these are the three different notation we consider. Let us take small examples first of all and illustrate it. For example, if you have the expression like A star B slash C, A star B slash anyway star and division. Okay. So the star and the division, both multiplication and division, both are having same priority. So if it's same priority, we will evaluate from left to right. Evaluate from left to right. Okay. So okay, anyway, so this is actually the infixed representation. Actually, this is infixed representation. And corresponding prefix representation is like this. That is slash star ABC. Okay. Slash star ABC. So this is infix. This is prefix representation, and the postfix representation is AB star C slash. This is postfix representation. Okay, normally I will tell you that how to get that. So normally for compilation and all, the evaluation expression, first of all, expression will be converted into postfix, then they do the evaluation. So this representation they use. So the user will give the thing in fixed representation in their code. So system will convert into whether you have parentheses or not parentheses or something like, no problem. So the expression will be converted in the postfix, then the evaluation will be carried out. So that's what we are going to see that. So before that, the question or doubt in your mind is how we get these things. This is very simple. So for example, this equation itself we can take, okay, that is A star B division C, right? Slash C. So here these two operators having the same priority, that is priority number 5, and against the evaluation is from left to right. So first we do evaluation of this, right? Then from the result we divide it by C. So next we do this. So if you make it full parenthesis, then this is what we get. Okay, now how I get that is in the prefix representation. If we give like that, this is infix, right? So prefix representation is what we have to do is the corresponding operator. The operator that should be moved to the corresponding left parenthesis. That is for this star, this is the parenthesis, right? This is the parenthesis. So this star should move to the portion of this left parenthesis. And the slash, anyway, this is the parenthesis, corresponding parenthesis. Okay, we have to move to that. So what happens? Slash star A, B, C. Then the operands will be coming. Okay, now in the postfix, what happens is you have to move this star to the corresponding right parenthesis. So it will come here and this will come here, right? So what we get? AB star C slash. So that's the way we have written. Okay, so this is the postfix. So this is the way we can consider manually how to convert into prefix or postfix. And one more thing is if you okay, before that I can have so another way is how we can do that is, so we can generate the evaluation tree also. We can generate the evaluation tree also. Anyway, now I think it is too early because tree traversal I have to teach. Okay, no problem. Anyway, that I can tell you when we deal with the trees. Okay. So anyway, now you assume that. So we have to give a full parenthesis, then we can move the operators to the corresponding left parenthesis, that gives the prefix. And if you move the operator to the corresponding right parenthesis, you get the postfix representation. So now we assume that the first we consider if the expression is in the postfix, how to evaluate. Okay. Anyway, what's the first equation? That's a little bigger equation, right? So first of all, we can convert into postfix as per the logic we have seen that. So equation is like this: A divided by B stars of C, and plus D star E, then minus A star C. So this is what the expression we consider. Okay, first of all, we can give the full parenthesis. Anyway, star having highest priority, so we have to put the parenthesis. Okay, remaining thing is lower priority. Next priority is division and multiplication. So this we can do, this we can do, then we can do. Okay, next one is next level priority. So plus and minus. So plus and minus means these two, then next minus. Okay, so we can give this is the fully parenthesis. Okay, now we have to give the postfix representation. Postfix representation is for star, this is the right parenthesis. For division, this is the parenthesis. Okay, for this multiplication, this one. then this plus this one, and for here this one, and this one. So we are going to convert this into a postfix. Therefore, after putting the parentheses, we have to move the operator to the respective right parentheses. Okay. So what we get? We get A, B, C, star star, slash. Okay. So you have to consider this a single operator, not two multiplication. Single operator, star star. Okay. Slash. So if any confusion there, you can use a different symbol. That is not a problem. Okay. Then here T, E star, then this plus, then A, C star, then this minus. So this is what the postfix representation of this particular equation. Now we assume that anyway the equation is already in the postfix. Okay, already the equation is the postfix, and how to evaluate that. Okay, first let me explain the logic. Then later on we can see how to evaluate. Okay, suppose I read the expression token by token. Token means the token will be either operator or operands. I will read the expression token by token. If I start reading from the left side, and we can assume that there is a special symbol called infinite, something like, okay. So when I reach this, I can assume that I reach the end of the expression, and against whatever I have currently, that will be the answer. So currently means where I have. So I am maintaining a stack. Okay, I will be maintaining a stack. So in the stack, whatever the answer there, that answer, whatever there on the top of the stack, that will be the answer. Okay. Now, when I keep on reading this, so the question is where I am going to use the data structure. That is also important. Okay, I can come to that point. So when I keep on reading from left to right, first token A, then token B, token C. Okay, no problem. I am not touching. So whenever I come to the star star, when I come to star star, so this is an operator, right? This is an operator. So as soon as I get the operator, I have to start evaluating the expression. So whenever I get the star star, this is a binary operator. Okay, this is a binary operator. And again, I need two operands. I need two operands. What are two operands? The two operands appearing just left to that. So B and C. So I have to get B and C, then I can evaluate B star star C. Then I can evaluate B star star C. Okay, now the question is, how will I get this B and C? Because my control, when you read something, the read pointer initially here, then here, then here, then here, right? So initial pointer that comes to this place. Then if I want to get that, then what happens? I have to move to location left, then fetch, then again I have to skip this, then come to next operator. So that will complicate, right? That will complicate. So we have to simplify that. So for that, what we do is we use the stack. So the stack is to store the operands. So whenever I get the operands, I put in the stack. And whenever the operator comes, I will fetch that much number of operands. That is, if it's a binary operator, two operands will be fetched, or if it's a unary operator, only one operand, something like that. Okay. So we will fetch the corresponding number of operands from the top of the stack, evaluate the expression, and put the answer inside the stack. Okay, now if I evaluate it, what happens is I am reading A. So what happens? This is our stack, right? This is our stack. So we assume there is a stack. So I got operand. So immediately I insert that operand into the stack. Then again I am getting B. That's operand. So I have to store it on the top of the stack. Okay, and we have to store that we know. Using push instruction, we can push it. Using pop instruction, we can pop it out, right? So using that operator, I am doing that, but I am not writing the code for that, because the last class we have seen the code. Okay, so you have to first implement the stack data structure. Once you have implemented, you can declare an object. So this object you can call the function. The function will do this insert and delete. Okay, this is what happens. So whenever you are being asked to write the code for evaluating expression, first of all you have to implement the stack. So without implementing the stack, you cannot do that, right? Okay. So now we assume that everything is there. Just explain the logic. So next, the token C. C is also an operand. Okay. So the C will also be written onto the top of the stack. Now what happens? Star star comes, right? Star star is operator. So this is a binary operator. Two operands that is needed. So I have to fetch the two elements from the top of the stack. Two elements from the top of the stack. So I have to fetch the C and B. Okay, C and B. Evaluate B star star C. So let us say that is T1. Okay. So answer is T1, temporary value. So we are evaluating B star star C and the result is T1, some T1. Then this T1 will be inserted here. Okay, now what happens? Your stack will be having A at the bottom. Then you will get T1 here, right? T1. Okay. Then after that, the control goes here, right? The control goes here. So when control comes here, there is an operator called a division operator. This is also binary operator, right? Is also binary operator. So if this is the binary operator, once again we have to fetch that much number of operands from the stack and do the evaluation, then store the results back in the thing. So now what are things you fetch? You fetch T1 and A, right? So fetch, when you do that, this is the order we have to maintain. Okay. So top one should come to the right side of the operator, and next one should come to the left side. So this is where we have to deal that. Otherwise, because otherwise you should not take something like T1 division A. Okay, the answer will be wrong, right? So now you have to do the evaluation, and you assume that the result is some T2. Now these two are been fetched, right? Now what your stack will be having? The stack will be having T2. So temporary value, that is T2. T2 is A1 divided by T1. T1 already we got from this, right? So that answer will be stored on the top of the stack, right? T2 is available. Next, what you get? You get D. So D is an operand. So that will be stored in the stack. Then next one is E. So E is also an operand. So that will also be stored in on the top of the stack, right? Okay. Next one is star. Star is an operator, multiplication. So it's a binary operator. So two elements we have to fetch. So what are the elements we fetch? We fetch D into E, right? D into E. D and E we will fetch, and the answer is D into E. So that we can consider T3, some T3. So that T3 will be stored again on the top stack. Now the stack will be having T2 at the bottom, and here you will be having T3. Okay. Then what happens? Next is plus operator. Plus is also binary operator. So you have to fetch two elements from the stack. So the what are the elements we are fetching? T2 and T3. So we will add T2 and T3, and the result we assume that it is T4, and hence your stack will be having, these two already fetched, right? The stack will be having T4 now on the top of the stack. Okay. Then next token is A, that is an operand we can insert into the stack. The next one is C, again operand that can be stored inside the stack. And the next one is the operator. So that's a multiplication. You can fetch A and C. So you have to multiply A and C. The answer, let us say it is T5. Then the T5 to be stored. Okay, the T5 to be stored inside the stack. So already T4 is there. Now T5 we are storing. Okay. Then next one is the minus. That's also binary operator. So we have to fetch that. So T4 minus T5 we have to do that. So we fetch it, right? So answer is, if the answer is T6, for example, then the T6 will be stored back into the stack. Okay. Now when you read the next token, this is infinite. Infinite denotes that we reach the end of the expression, and hence whatever there in the top of the stack, that is the answer. So T6 is your final answer. Okay, this will be your final answer. So this is the way we do the evaluation. Okay, so now we have seen the logic. Now accordingly we have to write the code. Okay, accordingly we have to write the code. So if you have the logic, there is no need to memorize the code. So otherwise, you see, when you deal with the algorithm codes, plenty of algorithms we write, right? Plenty of algorithms. So every problem you cannot memorize. Every problem you cannot memorize the algorithm. That is very difficult. All what you can do is you have to have the logic in your mind. So now I explained the logic for how to evaluate the expression. So immediately, whenever I ask you to write the code for evaluation, immediately you get the idea that you have the expression, the postfix, how you are reading one by one. So each token, whenever you are getting an operand, what you are doing, and whenever you are getting operator, what you are doing, accordingly, if you write the code, that will be easier for you to remember. There is no need to memorize or spending plenty of time to read it. Okay. Right. Okay. Now, just I transform this logic into the code. You see, this is algorithmic code. Okay, we are writing only algorithm. So that means we are not writing something like what we do in the programming. No, we can even write the pseudocode. So pseudocode representation only I am going to give that. So depending on the programming language you use for implementation, you have to convert the pseudocode in appropriate programming language. So that you have to do in your lab course. Okay. So for the theory part, we consider only the pseudocode. Okay, let me name the algorithm as eval. Eval. What we eval? We evaluate an expression E. So this is given as an argument. So now this argument is in the postfix representation ending with the infinite symbol. Ending with the infinite symbol to denote that's the end of this thing. Okay. So that is what we are passing as an argument, right? So that argument value is equal to E now. Argument is E. Okay. Now you assume that you are using the stack. Okay, you are using the stack. The stack implementation already I explained. So you assume that you have done everything. Okay, I'm writing code only for the evaluation. So initially we have to make the stack to be empty. Initially we have to make the stack to be empty because from the empty stack only we have to do that. So to make the stack to be empty, what we have to do? The top point of the stack should be 0. So if you put top pointer is equal to 0, the stack is empty. Okay, stack is empty. Then, so we have to do the loop forever. Loop forever. Okay, so we write like that. Loop forever. Loop will end with forever. Okay, I can write forever later on because I do not know how much space it will take. So actually, it's the construct is loop forever. It is something like repeat until. It is something like a repeat until. Okay. So repeat something until satisfying something else. But loop forever means it is an infinite loop, something like for semicolon semicolon. Okay, so there is no condition. So when we break is, so we give a breaking condition or return condition inside this loop. So this is an infinite loop, loop forever, infinite loop. Okay, now what we have to do? We have to read the token. So in the loop, what we are doing is we are reading the token one by one. So depending on the token we get, we have to perform appropriate action. Okay, so the first step is simple. It is only to make the stack to be empty. Okay, in the empty stack, we are trying to apply something. Okay, so here we are reading token by token. So X is the token. So we are calling a function called next token. Calling the function called next token. Next token of what? E. Okay. So this function, this is once again, actually when you are writing in the programming code, you have to do carefully. Maybe the expression is in the array. So maybe you can keep on moving the array pointer and fetch that. Okay. So depending on the language, you have to do that. But here algorithmically what we say is next token is a function that we consider as it will read a token one by one. So if I read first A, then next it will read B like that. Okay. Suppose your expression is this A, B star like that. First A, next time when I call, it will read next token like that. So this is what we assume. So the one we read is X. Okay. Now, depending on the value of X, we have to do something. So there is a case statement, or in C, it is like a switch statement, right? So depending on the value of X, there are different cases. So first case is, so if the X is equal to infinite, this is comparison statement, this assignment statement, right? So X is equal to infinite. So infinite stands for what? Infinite stands for end of the expression, right? end of the expression. So in this case, what we do, we will return. Okay, return. So and the answer, okay, once you return, you have to, if you want to get the answer, you have to fetch the value from the stack and return it, right? Okay, otherwise what we can say is, if we want the answer, then we can say that return with the stack. Okay, stack is our data structure. Okay, stack of top. So whatever there in the top of the stack, that will be given as answer and return from the code. So because it's an infinite loop, once you call this return, so it will stop. Okay, it will stop. So this is a termination condition. So whenever you are writing infinite loop, there should be at least one termination condition. Otherwise, it cannot be an algorithm. So because algorithm is supposed to terminate after finite amount of time. If it is not terminating, it is not an algorithm. So remember that. So there should be at least one termination condition. So whenever this infinite comes, so it will terminate. Okay. So next condition is, suppose whatever the token we read is an operand. Okay, X is an operand. So if X is an operand, what we have to do? We have to insert into the stack. We have to insert into the stack. So we will call the procedure. Okay, for stack we consider, for insertion, add. Already we consider add. So what we are adding? X. Where we are adding the data set is called stack. Okay, so otherwise you can give yes also, some name, some variable. My variable name is stack itself. Okay, if you use yes is the stack dimension, you can give yes, no problem. So stack, and n is the number of elements, the maximum size of the stack, and top is the top pointer. So this is what the code we have seen in the previous class, right? So now if X is an operand, then operand will be inserted in the stack. Already we have discussed with an example, right? So now that only we are doing. So there are three cases actually happens when we read token by token. So each token will be an operator, or it will be an operand, or it will be the end of the string, that is infinite, right? End of the string. Okay, there are three cases. So if the end of string comes, whatever there on the top of the stack, that will be returned and the program stops. So whenever operand comes, according to our logic, that should be inserted in the stack, and that is what we are doing here. Then one more thing is, the token will be an operator. Okay, the operator may be unary operator or binary operator, that we do not know. So depending on the operator, we have to perform, right? So if X, otherwise you can say else. Okay, so only three cases. So we can say else. So if these two cases are not there, then automatically it means it is an operator. So if it is an operator, what we have done? We have removed. Okay, so we have to remove the correct number of operands. Okay, correct number of operands for operator. What is our operator? X is our operator, because this is what we read. Okay, correct. Correct number of operands for the operator X from where? From stack. Okay, from stack. Then perform. Okay, after fetching that, we have to perform the operation. Perform the operation, and what we do? We store the result, right? We store the result, okay, onto the stack again, onto the stack. So this is what we do. This is what we do. So here anyway we cannot write, because it may be a different operator, right? So in the program, what you have to do is, you have to see whether it's a binary operator, then do that operation, then when putting back into that, in the program may differ, right? So but here it is an algorithm. This is in the pseudocode representation. Algorithm can be represented this way also. Okay, now all the three cases over, so we can say end of the case, and loop forever, and this will be repeated infinite time. So only when this condition comes, it will return the answer and stop. Okay, so this is what the evaluation. Okay, so any doubt you have? So if you have any doubt, you ask. Okay, now our assumption is, expression is already in the postfix representation, and system will make use of the stack. So this is an application of stack. Make use of the stack. Using the stack, it will do the evaluation. Okay, now what is the advantage of using stack here? Suppose I didn't use the stack. You assume this way, I didn't use the stack. Then what I have to do? I have to move the pointer to the left side depending on the operator. Then again you have to come back to the correct number of operator, or you have to remember that. So that will complicate the code. So the pointer will be moving left to right like that. Okay, so it will complicate, and you have to remember which operator you have considered. For example, if it's a unary operator, after performing the operation, you have to store the result where you store. So that is also you have to remember, and where you have to come back. So that particular point also you have to remember. So you have to have many variables and something like that. So it will complicate. But here, such things are not there. All what you have to do, you have to keep on reading the value one by one. You have to keep on reading the value one by one. So depending on the operand or operator, we can perform. So within linear time, what's the linear means? Linear means the size, the same size. Okay, if there are n tokens available, we will do n readings. Okay, with n readings, we can do that. So this evaluation expression can be done with the size of the expression itself. Okay, so if the expression is having n token, the time will be n only. Okay, because the loop execute for n times. Fine. Okay, now the next task is in only 5 minutes there. Not 5 minutes. I think time over, right? No, 5 minutes. 5 minutes there. 10, 15. Yeah. Next task is given an expression in infix representation with parentheses or without parentheses, how to convert in the postfix representation. Okay. So now once again for that we make use of the data structure stack. First, let us assume we have the expression that is a plus b into c. A plus b into c. Okay. So manually how to do that we know, but here manual thing we cannot perform because system cannot do put the full parenthesis and move the operator to the corresponding right parenthesis, not possible. So system should have a different logic, right? Suppose you have like that. In this case, once again I consider this an expression. I read one by one. Maybe you can put the infinite at the end to denote. Okay, that's up to you. Okay, now what it is doing is whenever it is reading an operand. So the logic is slightly different. Whenever it is reading an operand, it will output the operand. The previous case, whenever reading an operand was stored inside the stack. Okay, but here we will store operator inside the stack. So to convert from infix to postfix representation, all what we do is whenever the operand comes, we will simply write, and whenever the operator comes, we will store inside the stack. So when this is happening, here let us assume that next token is A. Okay, when we call that next token is A. So A is an okay. Here we consider three things. Next token, okay, next token, and here stack, and here what we output. There are three parts. There are three parts. So here the next token is A. So that time anyway your stack is empty because we are not writing anything inside the stack. Stack is empty. And what it output is, it will output A. It will output A. Then plus is coming. Okay. Then plus is coming. So plus is an operator. So whenever the operator comes, we will insert the operator inside the stack. So plus will come inside the stack. But output already A is there, the same output, no change, right? Output is A only. So don't assume that every time we are outputting A again. No. This output already whatever we got in this step, that is been retained. That's all. The next one is B. So B is an operand, and against the operand can be written immediately. Okay, so now your output will be AB, but already the stack is having plus, so that we maintain. Then what happens? You are getting another operator star. So now what we do, we got another operator, so that we have to store inside the stack. So already plus is there. On the top of that we put star. Anyway, this order, we assume that our stack is something like this. So plus is at the bottom and on the top star is there. Okay. So now star is an operator. So operator inserted, output is AB only. Then what we get? We get an operand C. So that time we will straight away write to the output. Okay. And here stack containing plus star. Stack containing plus star. Now what happens is when we read next token, that is end of the string. Maybe we have a special symbol like infinite or like. Okay. So when we reach end of string, then whatever there in the stack, we have to fetch it out and write into the output. Okay, now the next iteration, anyway, we reach end of string, so we will fetch the topmost symbol. If you fetch a topmost symbol, is it visible? Okay, topmost symbol, that is star, right? So what you get is AB star. Then after that, again, you will fetch another thing, that is plus. So AB C star plus. Then stack is empty, so we stop. So this is the postfix representation of this infix based expression, right? Now we take one more example. So that is A into B plus C into D. So let us consider this one. So here let us see what happens. So here also we take three columns. One is next token, and other one is stack, and the third one is output. So next token is A initially. We are reading one by one, right? We are reading one by one. Next token is A, and that time stack is empty, but it is an operand, so we output that value A. So next one is star. Okay, next token is star. That is operator. So the operator will be inserted the stack. So in output there is no change. Whatever we already written, that will be there in the output. Okay, so A. Then after that, next token is left parenthesis. So when the left parenthesis is a new symbol, apart from operator and operand, because last example, this parenthesis is not there. Now we are considering the parenthesis also. So whenever the left parenthesis comes, that should also be inserted into the stack. Okay, so remember, whenever left parenthesis comes, that should be inserted in the stack, and output there is no change. So A is there. So next one is B. So B is an operand. So what we do is we write B. Okay, so the output now containing AB. So stack there is no change. Stack there is no change. So next operator plus. So plus is an operator, and hence that can be inserted into the stack. So remember, stack is going this order. So this is the rightmost symbol is the topmost symbol, right? And output there is no change, AB. Then next symbol is C. Next symbol is C. So if C comes, that's the operand, and against we can output C immediately. So the output containing ABC. However, the stack there is no change, right? So star left parenthesis plus. So same thing will be maintained. Okay, now another new symbol is coming, that is right parenthesis. So when the right parenthesis comes, what we got to do is we have to hope some symbols from the stack till you get the left parenthesis. Till you get the left parenthesis. So that's why already whenever the left parenthesis comes, we inserted the stack. So after that, whenever the right parenthesis comes, we have to pop out the operators which are there in the stack until we get left parenthesis. So if we do that, what happens here? A, B, C, we are taking the operator plus, so we output that A, B, C plus. Then next one is, once this has been removed, next one is left parenthesis. But left parenthesis, what we do is we won't write, but the corresponding right parenthesis we encountered. Okay, that should also be removed. So only the operators we have to given for output, but left parenthesis we should not write here. Rather, we have to remove from the stack. So after removing this plus and left parenthesis, the stack will be having only star. Okay. Then next symbol, that is star. This is the operator. Okay. Now already we have ABC plus, right? Already we have ABC plus. Okay. Now when the star comes here, we have to be very careful, because the same star already there. In the previous example, it was not like that. The different operators are there, right? So here the same operator comes. So here what we are to do is, whenever the same operator comes, we have to, it is not like same operator. Even what we do is we assign some priorities for each and every operator. That is in-stack priority and incoming priority. Two kinds of priorities we assign. So in-stack priority is whenever the operator is inside the stack, what is the priority value? And the incoming priority means whenever the operator that we are reading, okay, so that time it may have some priority. So we are assigning two different priority. Why we are doing that is because in the last class, we discussed that the operators having highest priority, that is priority number 6. Okay, so that will be evaluated from right to left, and all other operators we evaluate from left to right. Okay, so this left to right, to manage that, we are giving different priorities, because this is the expression that gives in the positive form. Okay, based on that, only the evaluation procedure will do that. So according to the logic what we discussed, we have to get the postfix expression properly, right? So therefore, what we do is we assign two different priorities. Okay, let me give the priority, then I can explain here. So how we set the priority is, here we consider symbols. Okay, then ISP, that is in stack priority. In stack priority. Another one is in ICP, incoming priority. So in stack priority and incoming priority. Okay, so if the right parenthesis comes, we are not assigning any priority, because right parenthesis we are not doing anything with that. As soon as right parenthesis comes, we simply pop out till we get the left parenthesis. So there are nothing required. Only whatever we are inserting inside the stack, we need it, right? So right parenthesis we are not considering anything. But if the star comes, okay, star comes, in stack priority is 3 and incoming priority is 4. Okay, because this is the operator of higher precedence. Okay, then okay, I am not writing for all operators. So for operators with the highest priority, what we consider, you have to define like that. In stack priority should be less and incoming priority will be larger. Okay, but all other operators we set the same priority, because the evaluation is from left to right. So I am considering only a few. Okay, now if star or slash comes, the in-stack priority is 2 and incoming priority, that is also 2. And similarly binary plus or minus comes. Okay, binary operators. If it comes, this is 1, this is 1. Okay, and if left parenthesis comes, then what we have to do is we have to pop out something, right? Okay, so here in stack priority is 0, but incoming priority is larger. So we have to store that. Anyway, left parenthesis comes, we have to store that. Okay, so we are setting this 0 and this 4. So these things we can consider for the time being. Okay, like that for remaining operators also you can define. So remember, whenever the highest, whenever we want to execute from right to left, we have to do like that. In stack priority should be lesser than incoming priority, but left to right the same priority value can be set. But this is a special case. So there simply we have to insert the stack. Therefore, we are setting lowest value here and highest value here, right? Okay, if you do like that, it will do properly. Okay, now the star has come. Here also star there. So this is in stack. For this you have to consider in stack priority, and for this you have to consider incoming priority. Okay, so this star having priority number 2, and this star that is also having priority number 2, because in stack priority and incoming priority both are same. So here also 2, here also 2. So the condition what we say is, if the in stack priority is greater or equal to incoming priority. Okay, so whatever the suppose the operator comes, if the in stack priority is greater than or equal to also will come. Okay, then what we have to do is we have to pop out the operators there in the stack. So if maybe more than one operator also there. So here only one operator. Sometimes if two operators having the same priority, both operators will be popped out one after another. Okay, now we have to pop out this operator, this star, not this star. Okay, the operator which is there already in the stack, that will be popped out. Don't ask why this, what is the difference? No, because we have to write the programming logic. Okay, so sometimes it may be star, sometimes it may be slash also. Okay, so that's why we are not saying about whether this or this star or this. So whatever is there in the stack, that we have to remove. So if you remove, you get star. Okay, and now the stack is empty once you remove. But this one more star is coming in, right? So after popping out all the star, all the operators having same priority, okay, out, then whatever is remaining, but here the remaining is empty. Then after that, the incoming operator should be stored inside. Okay, now this star is this one. This star is this one, right? Okay, so remember the star inside the stack has gone there, and the incoming star we stored in the stack. Okay, so these two are different. Now after the star, you are getting operand D. Okay, your stack no change, but here what we do is we will write the operand at the rightmost side. Okay, so plus star this. Okay, now the infinite symbol comes. Anyway, we assume that there is a infinite symbol at the end. So stack already star is there. So once this symbol comes, whatever is there in the stack, that should be removed. Okay, so now stack is empty, and here it is ABC star, sorry, plus, right, plus star D star. So this is what the postfix value. Okay, now if you put the full parenthesis here, what we get? We get like this, right? So sorry, we put the full parenthesis, we get like this, right? So now in the postfix representation, we have to move the operators to the corresponding right parenthesis. So the plus comes here, this star comes here, and this star comes here. So if that's the case, what you get, the postfix representation will be this one, right? Okay, so this is what we do. Okay, now based on that, we can write the algorithm. Now we know the logic. Okay, based on the logic, we can write the algorithm. So we can name the algorithm as postfix, and the argument is E is an expression. Expression end with the infinite. Expression end with infinite. So once again, we are assuming that we are using stack. Okay, stack already been created. All what we do, we have to initialize the stack. So in the previous case, for initializing, we put top is equal to 0. But here, what we are doing is, we are putting some special symbol. Okay, we are putting a special symbol inside the stack, because the removal is based on the in-stack priority and incoming priority. Okay, so for that, for applying that, if you make no symbols at the bottom of the stack, then the condition will be violated. So what we are trying to do is, we are initializing stack with some value. Okay, stack, that is currently the first portion. Okay, we assume that the stack is starting with the index value 1, 2, 3, like that. So first position, we put minus infinite. Okay, and once we insert the value, the top pointer will be moved to that. So top is equal to 1. Okay, top is equal to 1. Now you remember the in stack priority. Suppose we put minus infinite, whatever we are inserting the stack, we have to define in stack priority. So we assume that the in stack priority of this minus infinite, that is equal to -1. So if you said that, then conditions will not be valid. For example, if you have some operators stored, and if you keep on fetching, anyway, it will stop once it reaches minus infinite, because in stack priority is if it is greater, that is in stack priority is greater than incoming priority, then only it will fetch, right? Otherwise it won't. So this is the least value. Already we set up to 0. So we are setting a value which is lower than that. So -1. So that minus infinity cannot be popped out. Okay, minus infinity cannot be popped out. So just for that only we are doing. Okay, now like in the previous one, we can consider infinite loop forever. Okay, that will be repeated until some condition where we terminate. So we are reading token by token. So x is equal to next token from the expression E. Next token from the expression E. So it will read token by token. So based on the token value, there are several cases. Okay. The first case is x is equal to infinite. Okay. So you have an expression and the expression that ends with the infinite. So if the infinite is arrived, so that means you reach the end of the expression. Okay. So if you reach the end of the expression, you have to pop out, okay, all the values available in the stack. You have to pop out all the values available in the stack. So all the values available in the stack is anyway that position 1 containing special symbol, that should not be popped out. Okay, that should not be popped out. So up to 2 we have to pop out. So what we can do is we can put a while loop. So while this top is greater than 1, because top is equal to 1 means minus infinite, that we are not removing. So from 2 onwards, I mean up to 2 only we are removing. Okay. So if while top greater than equal to 1, 2, so what we got to do is we have to print whatever is there in the stack of top. Okay. Then after that, we have to change the top pointer. Top pointer should be decremented. Top is equal to top -1. Okay. Now this while end. So this is the while end. So these two statements will be executed in the while statement. So what we are doing is we are taking one element from the stack, writing to the output, then another one like that until it is reaching this minus infinite. Okay. Then after that, anyway, based on that, now already we reach the understand, right? Then we are getting the expression. Then the expression should be end with infinite. Why? Because that expression is going to be evaluated. So for evaluating, once again the expression should end with infinite. Okay, so that infinite we have to write. Therefore, we can put a one more print statement, print infinite. Okay, so this is only to make the expression, the postfix expression terminates. Okay, then after that we return, because in the for infinite loop, for loop forever. Okay, infinite loop, there should be some condition, it should return, right? So after this, it will return. Okay, then next one is, next case is x is an operand. Okay, x is an operand. So if x is an operand, what we do? We simply write. Okay, in the example, whenever the operand comes, we simply write. So we can say that print x. The x will be given to the output straight away. And next case is x is equal to the right parenthesis. Okay, x is equal to the right parenthesis. So if it's a right parenthesis, what we have done? We have removed all the operators up to getting a left parenthesis. Okay, we have to remove all the operators up to getting the left parenthesis. So once again, what we can do is we can put the while statement. So while stack of top. Okay, we are checking whether it's a left parenthesis or not. So while stack of top not equal to left parenthesis. Okay, that means until getting the left parenthesis. So do what we got to do? We have to print whatever there in the stack of top. Okay, Then after that, what you have to do? You have to so you have to move the pointer down. Okay, so top is equal to top minus 1. Okay, then end. So the while loop end. So until getting the left parenthesis, we keep on removing the operators and write into the output. Then after what happens, the left parenthesis will be there, right? So that should also be removed. That should also be removed. So how we remove that? So that will be removed by making this pointer, top pointer as top minus 1. So that means once again we are bringing the top pointer down. And again that symbol now gone. Okay, because next time another symbol comes, it will overwrite, right? So by setting top is equal top minus 1, the left parenthesis will be removed. Okay, then else for all other cases, what we do? So all other cases means what are the cases? Operator. Okay, so remaining cases either operator or left parenthesis. You know, left parenthesis also we assign the priority, right? So everything can be dealt with that. So there, what we do, what we are doing is while in stack priority. In stack priority for what? Whatever is there in the stack. So in stack priority are the topmost element. Okay, stack of top. Okay, in stack priority stack of top. Okay, so if that is greater than equal to the incoming priority of the X is the next token. What are the operator we read? Okay, so if the in stack priority of the topmost element of the stack we are comparing. So if it is greater, then that will be removed and will be returned and the output. Otherwise, what we do is we will insert that, right? So we are checking that, and if that's the case, we print stack of top. Then what we do? Top is equal to top minus 1, right? Top is equal to top minus 1. Then end of the while loop. Okay, now after that, what we do? So we removed those operators having same priority or more priority from the stack to the output. Then whatever the incoming thing is there, right? So then we have to write. Suppose this is also not satisfied. Straight away the control comes there. Therefore, we are calling the procedure that is adding the value to the stack and operator X to be inserted where in the stack size is n and topmost pointer value. Okay, so we call the add function and the value will be inserted into the stack. Okay, so these are the 4 different cases possible. How I have written is, anyway, with the example I explained how it works. So based on the logic only, I have written the code. So if you remember the logic, you can straight away write, right? So absolutely no problem. Okay, now the case end here, then loop forever. Okay, case end, then loop forever, finishing. Okay, so this is the algorithm for converting infix expression in the postfix. Okay, so this is what the system generally does. Okay, then once the expression is in the postfix, and based on our evaluation procedure, we can evaluate. So once again, if you look at the complexity, you see all what we are doing is number of times this loop iterates, because all other statements we have given here, one assignment, something like that. Only these places taking extra time. Okay, these places taking extra time. But again, I can come to that. But if you take a loop forever, okay, so this case statement will be executed for every token. Okay, every token. But once a token is considered, the same token will not be repeated. So if the number of tokens is n, then this are the length of the expression is n. So this loop forever cannot exceed beyond the value of n. So within order of n time we can do that, right? So however, you may get the question that sometimes, because if you look at the statements inside the case, okay, inside the case, some assignment statement there, some written statement, print statement, something like that. Okay, we know these statements will take only 1 unit at a time. Okay, fine. But the question is, somewhere we are using a while loop. For example, here we are using a while loop, here another while loop, here another while loop. The question is, this while loop can iterate for several times. Okay, So whether these iterations will increase the time or not, actually it is not increase, it won't increase. Why? Because if you look at this while loop, whether this, whatever it may be, all what we are doing is we are popping out elements from the stack and the element that will be returned into the output. Okay, so what are the elements we are popping out from the stack that will be returned into the output, right? So now you see once the element that is been so okay, if you take an what we are inserting in the stack, we are inserting only the operators or left to parentheses. Okay, nothing else. We will insert either operator or left to parentheses. But remember, those operators will be inserted only once, and it will be removed only once. Okay, once that is the removed operator will not be again inserted into the stack, right? But the number of operators cannot exceed the length of the expression. If the length of the expression is n, the number of operators will certainly be less than n, right? So each of those operators will be inserted exactly once in the stack and also removed exactly once from the stack. Okay, therefore, number of times totally these while loops will be doing even in within the forever. Loop forever. So okay, number of times totally this while loop will do cannot go beyond n. Okay, maybe this will take n time and this will take another means n plus n, that is 2n. Asymptotically, this 2 is not a factor to be considered, right? So within order of n time we can complete it. So the time complexity is order of n only. So for conversion of infix expression to the postfix will take order of n time. Similarly, once postfix representation is given, the evaluation will take once again order of n. So with linear time, so this complexity is called linear. Already explained what is linear, what is exponential, what is polynomial, what is something like that. Okay, polylogarithmic, all those things. Therefore, this can be done in linear time. So this is a very efficient algorithm, an optimal algorithm. Because why we are saying optimal? Anyway, if you have an expression, if you read the expression token by token, anyway you have to spend n unit of time. So for reading time is there. Okay. So the any algorithm with the complexity of the same order of n, so it will be optimal only. Okay.